రే సౌండ్ తగ్గించరా. Yeah. Good evening, guys. Tell me, what are your doubts?
So, question number 14.
Question number
14.
14. That is which term? I mean, which part? First part or second part?
Part 1, sir.
One minute. Part 1, 14th. This one, huh?
Yes, sir.
This EMF of a cell. Okay, what is the idea you got? So they are saying for a cell, the terminal voltage is 2.2 volt. Right? When the circuit is open and reduces to okay. So EMF of the cell is 2.2 volt. When the circuit is open, it reduces to 1.8 volt when the cell is connected to a resistance of capital R, which is equal to 5 ohm, and V is equal to 1.8 volt. The value of internal resistance. So the value of internal resistance is capital E minus small v divided by capital R. This is the formula. Sorry, capital E minus small v divided by V into R. Okay, I'll tell you why it is so. So if the cell is having EMF E and this is R, then the potential difference across the cell is what? How is the potential difference related to EMF? So V is equal to E minus IR. I hope you know this. So E minus I is how much? E divided by capital R plus small r into R. When you solve this and find the value of small r, you will get this formula. So E is 2.2 minus V is 1.8, the whole divided by 1.8.
But they've given only one V as 1.8 only, sir. But how did you take small v and capital V, sir?
Remember, the terminal potential difference is 2.2 volt when the circuit is open. So what is the terminal potential difference when circuit is open called as?
EMF.
That's what I took. And it reduces to 1.8 volt when the cell is connected. Means this is the potential difference.
Yes, sir. But in the formula, you said EMF minus small v divided by capital V. That's why I asked.
You have to solve this. You have to solve this. You have to solve this. Because smaller is here. No, that part I left it to you.
Okay, sir. Okay.
So V is equal to E minus E divided by R plus R into small r. No. So E minus V is equal to E divided by capital R plus R into small r. Okay, I'll do one thing. I'll take LCM here itself so that things will be simple. So V is equal to ER minus E small r divided by capital R plus R. This and this will get cancelled, which implies R plus R is equal R plus R into V
Into V
is equal to E into capital R. right?
Yes, sir.
Did I miss something? There's not dimensionally right, wrong also. Correct. VR plus V smaller is equal to ER. This will go to the other side. V smaller is equal to ER minus VR. So R will be equal to ER minus V capital R divided by V. So E minus V divided by V into capital R.
Okay, sir. Understood this.
Yeah. So there is an important formula. Remember it. E minus V divided by capital V into capital R.
So we have to just substitute the values and get smaller, sir.
That's it.
Okay, sir. Thank you, sir.
By now we would have got it actually. 0.4 divided by 1.8 into 5. So 4 divided by 18 into 5, that is 20 divided by 18. 1 point something. 20 divided by 18 means 10 divided by 9. We have an option. Huh? This is the answer.
Okay, sir.
Next.
Sir, I have a doubt in the fifth one, sir.
What is your doubt in this?
Sir, how to find the magnitude of the...
Q divided by 4 pi epsilon naught into R square. Here R will be root of x square plus y square. That's it. X coordinate is given, y coordinate is given. So with respect to origin, what is the distance? It is root of x square plus y square. That part you can do?
Yes, sir. Yes, sir.
Next.
Sir, I have a doubt in the 11th one, sir.
The current I in the circuit, this cell and this cell, they both are in series, but they are connected in opposite directions. So I1 is flowing like this, I2 will flow like this. So the net EMF of the circuit is how much? The net EMF will be 3 volt and the net resistance will be 30 ohm. Now you can calculate the current I is equal to 3 divided by 30. 0.1 should be the answer.
Okay.
Yeah. Next.
Sir, in the 29th question, G option, I don't know the answer. Fill in the blanks.
1 minute.
Okay, sir.
Tell me.
Sir, 29th question, sir. G option, the ratio of charge to potential of a body is known as. I don't remember that, sir.
Sorry, I missed it again. Which question number? Sorry. 29th.
Yes, sir. G option. Sorry, G subdivision.
Ratio of charge to the potential of a body is called as capacitance.
Okay, sir.
That's it. This paper is over.
Yes, sir.
Okay. What about the doubts in the other?
Sir, in the part 2, I have a doubt in the 10th question.
10th one.
Yes.
Actually, we need not do this because you don't have the concept of magnetizing current and all those things. Not needed. I didn't see this. Yeah. Next.
So in 19th century.
A 200 ohm resistor is connected in series with a 5 microfarad capacitor. The voltage across the resistor VR is how much? Now the capacitive reactance. So there is a resistor and a capacitor. Both are connected across resistance and capacitor. VR VC is equal to how much? Okay. Since you know the value of VR here, okay, VR instantaneous value is given, which is 1.2. Correct?
Yes, sir.
So how will you find the RMS value across this? 1.2 divided by root 2. So once you get the RMS value, you find the current across the resistor. Once you know the current across the resistor, the same current will pass through how much the capacitor, because they both are in series.
Parallel.
Let's say
So
the
this
current
is
comes out as I, then I will be equal to V, that is a potential difference across it. Actually not needed. All these are unwanted data. So you want the capacitive reactance, right? Xc is equal to omega into C. Omega is 2500 into C is how much? 5.
5.
X is equal to 1 by omega C. Sorry. 1 by omega C. 1 divided by omega is 2500 into 5 into 10 power minus 6. So 1 divided by 25 into 5, this would be 10 power 3. 10 power 3, 10 power 6 into 100. These two will get cancelled. 10 power 4. So 10,000 divided by 25 into 5. This will give you 2000. 2000 divided by 25 is how much? 8 here. That should be there.
Yes, sir. 80, sir.
That's the answer. Next.
Sir,
Tell me.
sir, I have a doubt in the 42nd question, sir. The first 4 subdivisions I don't know how to do. I tried, but I'm getting the wrong answer.
40?
42nd.
What is that you didn't get? When the frequency of AC supply is such that the inductive reactance and the capacitive reactance become equal, that's called as resonance.
Yes, sir.
The impedance of the LCR circuit is equal to the ohmic resistance in the circuit. Such a series LCR circuit is known as a resonance circuit. Okay, and the frequency of the AC supply is known as resonant. Resonance phenomenon is exhibited by circuit, both RL and resonance circuit. We cannot have resonance in an RL and RC circuit. Okay. Sorry. A series LCR circuit. What is your doubt?
Sir, should we find the
Don't have an
frequency
answer
first?
for that. Is there something else I can help with?
Sorry. Yeah, tell me again. Find the value of source frequency for which the amplitude is maximum. Now, what is your doubt? Tell me now. Sorry. Yeah, proceed, Nandakishore, proceed.
Sir, I don't know the formula for it, so I don't remember it very well.
Find the value of source frequency for which the amplitude is maximum.
Yes. So should we find the frequency or the current?
Yeah, a source frequency then asked. Yeah, the source frequency, for which the current is maximum. Correct? Huh?
Yes, sir.
So the maximum current will get generated V0 divided by R.
Okay, sir.
But under resonance, since they're asking frequency, omega should be equal to 1 by omega c. So omega square is equal to 1 by LC. You calculate the value of omega from here.
Okay, sir.
But that omega will be in terms of radian per second. But they ask the source frequency, so F will be equal to 2 pi by omega. So whatever answer you get, divide 2 pi with that answer, you will get the required answer.
Okay, sir.
Okay. So generally, this level of calculations, I don't think they should have, but it takes a lot of time. But let's see, you keep practicing these things also. The value of maximum current is how much? So maximum current is obtained when the circuit is in resonance condition. So V0 divided by R.
Yes, sir.
So V0 is how much?
230.
230 is not V0, it is VRMS. I told this many times. If they give only one number, it is always RMS value. If they give, see, for example, in that problem, they give 230 sine omega t, then this will become V0. Okay, so V0 is root 2 times 230, the whole divided by R is 23. So you should go 10, 1.414, the answer.
Okay.
The value of maximum power. So power is equal to I0 square into R. But since there is an RC circuit, you have to write P average is equal to ERMS into IRMS divided by 2. So it should be, you should write those values and then write. Next.
So then the Q factor.
Q factor is 1 by R into root of L divided by C.
So I should just add to substitute everything and
yeah, most all the problems your work is you need to substitute and print this.
Okay, thank you. Yeah.
Anything else? That's it. Yeah. What is the next doubt?
So the 23rd question, the answers both are false. The assertion reason.
1 minute, ma. Can you repeat again? Which question?
Yes, 23rd, sir. The option, the answer is both are false, but option is not given, I guess.
A direct current flows through a metallic rod. It produces magnetic field only outside the rod. Okay, what is your opinion?
So it will be false. It will be false.
Because it can produce inside also.
So can you repeat it?
No, when you take a metallic rod, when the current is flowing on the circumference, it can have magnetic field here and here also. But I told it magnetic field only outside, so it is false. Correct. False is correct. Next. There is no flow.
There will be no.
there is no flow of charge carriers inside the rod.
Yes, sir. If it's flow outside, how will, the charge will definitely zero. So.
I didn't get you. There is no flow of charge inside the rod. What is your answer?
That is false, no, sir.
Why?
So because the magnetic field produced outside, how the charges will be.
Direct current flows, so it produces magnetic field. It should be true only, no? Because there is no. It is going to flow only through a medium. Right? Inside it is going to be hollow. Where will the charges flow? So it should be true only. So A is false and R should be true actually.
Sir, I didn't get you, sir.
I'm saying, read the question. No, there is no flow of charge carriers inside the rod. So imagine this is a hollow rod, and where are the charges going to flow? They are going to flow on the surface of the conductor only. No, why would the
Yes,
charges flow inside when it is going to be hollow?
Okay, there's a no flow of charge. Okay, sir. I read the question.
But anyways, it's slightly ambiguous. Okay. Anyways, next. Next question. That's it. No other doubts? If there are no doubts, we can wind up, no? Yeah, before that, wait, guys. Tomorrow and day after tomorrow, you'll not have any class or anything. I want you guys to work on the chapters. Next week, I will conduct a test. Okay, next week there will be a test on Monday, Tuesday, and Wednesday we'll have a discussion session if possible, or Wednesday also I'll conduct a test. And from 20th of September, I'll start term 2. Is that clear?
Sir,
Yes,
sir,
Tell me.
sir, from next week till 22nd, I have midterm exams, so terminal exams.
Okay, okay. That is the case, you drop me a message. That's it.
Okay, sir.
Okay, that's it. So have this in your mind. So tomorrow and day after tomorrow, it's like study time for you guys. You sit and work. And next Monday, Tuesday, Wednesday, we'll have tests. Okay.
sir, I have a doubt in 33rd question.
30.
3.
Okay. Capacitor serves as a block for DC and offers an easy path to AC. What do you think is the answer?
Yes, sir, it's true. Capacitor serves as a block.
It is true because XC is equal to 1 by 2 pi into F into C. F is 0 for DC. XC is infinite. 1 minute, wait, my pen stopped writing. So that is true. Capacitive reactance is inversely proportional to frequency. That is also
True. Sir, but sir, is it the correct explanation?
yeah, it is. Because XC is equal to what? 1 by 2 pi into F into C. F is 0 for DC. When you substitute 0, you will get XC is equal to infinite. So when it is infinite, it does not allow the direct current to flow through it.
Okay, sir. Sir, and 35th second subdivision, sir.
Magnetic field can be okay by its third law. Second subdivision, what are the magnetic field due to a current carrying to a current in a straight wire of line segment L at a point on its perpendicular bisector at a distance R from it. So due to a straight wire, what is the magnetic field at a distance P from it? Sorry, at a distance R from it at a point P. B is equal to mu naught I divided by 2 pi R. So B is inversely proportional to R.
The same question, fourth one, sir.
Okay.
Sir,
A long straight wire carries a current along the z-axis for wait. A long straight wire, long means infinite length. Straight wire carries a current along the z-axis for any 2 points in the xy plane. Which of the following is always false? Question is slightly. A long straight wire carries a current along the z-axis for any 2 points in the xy plane. Oh, current carries there should be a comma. There is a long straight wire which carries a current along z-axis for any 2 points in the xy plane. Which of the following is always false? The magnetic fields are equal because it's not possible, right?
yes, sir.
Wait, let me check. The directions of the magnetic fields are same. Okay, the magnitudes of the magnetic fields are equal. The field at one point is opposite to that of the other. That is right. The magnitudes of magnetic fields are equal. This should also, according to me, A, B, and C, all the three should be wrong. For any 2 points in the xy plane, no, A, B, and C. Actually, they should have asked which one of the following is true, then the answer would have been D. No, wait. Both the points can be in the okay. We have to read the question. Which of the following is always false? See, there is a current carrying conductor. Let's say it is in the current is going in the z direction. If I take one point here and another point here, then there is a possibility that the directions of magnetic fields are same. Then there is a possibility that the magnitudes of the magnetic fields are equal. The field at one point is opposite to the field at the other point is right. Then the magnetic fields are equal should be false. That's the answer.
Okay, sir. Then the last question is 39th fifth subdivision.
39th, 5th.
39th.
Select the correct options from the following. The magnetic dip is 0 at the center of the earth. The magnetic dip is 0 at the center of the earth. Wrong. Magnetic dip decreases as we move away from the equator towards the magnetic pole. Yes, that's right. Magnetic dip decreases as we move from the equator towards the magnetic. No, it should increase because the magnetic field dip at the pole should be maximum. Magnetic dip increases as we move from equator to the magnetic pole. That's right. So please make a note of this. Magnetic poles at the equator is 0. Magnetic dip at the equator is 0. Magnetic dip at the poles will be 90 degrees. So have this in your mind. So as we move from equator towards the magnetic pole, the magnetic dip increases.
Sir, it's option B, sir.
C.
Increases.
Hmm. Okay.
Sir, last question, sir. Sorry, sir. 9th one, sir.
No problem. 9th one. Huh?
Yes, sir.
When a short bar magnet has a magnetic dipole moment of 0.2 joules per Tesla, then the magnitude of the magnetic field produced at a distance 8 centimeters from the center of the magnet on the equatorial line. See, what is the electric field at equatorial point? Kp divided by r cube. No? K is 1 by 4 pi epsilon naught. All those things are there. Now, magnetic field at the equatorial point will be mu naught by 4 pi into m divided by r cube. So m is known, r is known. Substitute, you will get the answer.
Okay, sir.
So it should be 2 into 10 power minus 4.
Fine, sir.
Okay.
Yes, sir.
Any other doubt? That's it.
Yes, sir.
Okay. Okay, then we can wind up. I'll see you all later. Yeah, guys, we can wind up.
Thank you, sir.